All right, so let's talk about hypothesis tests for one population mean when the standard deviation of the population is known. Sort of a key fact to keep in mind here. We're going to be using a z-value, that is a normal distribution, to help us do that. When do we know when to do that? Well, for small samples of size less than 15 or so, the z-test should only be used when the variable under consideration is known to be normally distributed or very close to being so. If it's any other distribution, no way. For samples of moderate size between 15 and 30, the z-test can be used unless the data contains outliers or the variable under consideration is far from normally distributed. But for large samples, say of size 30 or more, remember from the central limit test, that's the central limit theorem, this is what we could say, the z-test can be used essentially without restriction. However, if outliers are present and their removal is not justified, you should perform the hypothesis test with the outliers and once without them to see what the effect of the outliers might have. In reality, that's what we try to do. But if the conclusion is affected, we're going to use a different procedure or take a different sample if possible. If outliers is present but their removal is justified and the results of the data for which the z-test is appropriate, then the procedure can be used. All right, so keeping all of that in mind here, let's go through an example using a problem similar to the one that you'll find in WebAssign to do this. So from generation to generation, the mean age when smokers first start to smoke varies. However, the standard deviation of that age remains constant around 2.1 years. A survey of 40 smokers in this generation was done to see if the mean starting age was at least 19. The sample mean was 18.1 and the sample standard deviation was 1.3. Do the data support the claim at the 5% level? Well, the first question we have to ask is, well, what is the claim? Well, our claim is this. We're being told that the generation to generation, the smoker's age varies, but in this generation, the mean starting at least 19. Well, right there, that should give you a hint. This is our claim, right? So our null hypothesis claim right here is that the mean is at least, right? We're gonna say that our mean is at least greater than or equal to 19. Now, what we're really saying right here is that we're looking at the average test, right? The average age at which we begin smoking. So our alternate hypothesis, HA, is going to be the mean age, well, it's less than 19. Right? Now, let's use this information right here and discuss this using Excel. So we're going to go to Excel here, and this is the program, my Chapter 9 Hypothesis Test-o-Matic. In the Hypothesis Test-o-Matic program that I've written, what we're going to do is we're going to enter in our null hypothesis for our z-score, right? So we're going to enter in a z-test, right? Because we've got a sample size of 40. Well, our claim is that the mean is greater than or equal to 19. And we're going to test that against the claim that the mean is less than that claimed mean of 19. So we're going to choose, in this one, we have a choice. We either put in A, B, or C. So we're going to go ahead and put A to represent that. Our sample size is 40. Now, in the reading, the sample mean was 18.1 years of age, and the standard deviation, well, for standard deviation, we actually have to use the one that's given for the population. And we're told that it's given as 2.1 years. Yes, I know that we were told that the sample standard deviation was 1.8 years, but in this case, 2.1 years is the population standard deviation, and in a z-test, we assume that we used that standard population. Finally, it told us that we were going to test at the alpha level desired with our level of significance is of 5%. So 0.05 is the number that we want. Okay, so what does this tell us? Well, first of all, this tells us that our z-score here is negative 2.75. So if we're using our standard deviation, what we're saying is that the z-score represents the test statistic. And so our test statistic here, our critical value, would be formed at negative 2.7. And the p-value that we get is 0.00336. All right. So what could we say then? Well, let's go back to our sheet right here and work this out. The average age that smokers start to smoke right here is what we're actually looking at as our reference right here. And what we're going to do is we're going to use the test statistic, 19, and then 0.3320. So in our Excel spreadsheet right here, this number represents that value. So in this value, this is going to be sigma divided by the square root of our standard deviation. Square root of our, divided by the square root of our sample size, right? So that's the one that we want if we're going to find these values that we're looking for. All right, so this will be posted on the Canvas board for you guys to look at. All right, so what else can we tell now? Well, what is the p-value? Well, we found a p-value equal to 0.0034. And what does it mean? Well, if the null hypothesis is true, then there's a p-value chance that the average age at which people begin to smoke is at least 18.1 years or less. Well, keep in mind our null hypothesis right here and our alternate hypothesis, right? We're looking to test this decision. So what could we say? Well, our alpha level is 0.05, the level of significance. And since our p-value is less than that value, right? If the p-value is less than alpha, then what we're really saying is that we have enough evidence to reject the null hypothesis. Right? So alpha is greater than p, and we reject the null hypothesis. And what's more, we come to the conclusion that there is sufficient evidence to conclude that the starting age is less than 19, right, which is our alternate hypothesis. And if we look at the situation right here, right, this is our p-value region right here, and our p-value is clearly falling within that orange region, which is outside of our rejection region, of our accepting region, right? So this is actually falling within the rejection region. Now, one more look at our spreadsheet right here, you'll notice that what I've given here is a 95% confidence interval about our actual mean. And here it is. Our mean is 18.1 years of age, right? But if we were to find our critical region, right, our standard region says that, well, the age at which smokers start, we have a 95% confidence that it's going to be somewhere between 17.4492 years of age and 18.75 years of age. What does that mean to us? Well, our null was that the average age is greater than or at least 19 years of age, but 19 years of age does not fall within that confidence interval. And since that's true, then what we're really finding here is that our critical value is actually somewhere up here in this red region up at the top. And that's a good thing to know. All right, so that's this problem right here. We'll try one of a different sort in a minute. Stand